Hi everyone, my name is Colin and today I'm going to talk about integrations and infinite series problem. So let's start with integration. Integration is basically calculate areas under the curve, and infinite series is sums that go on forever. So as the example you can see, the answer is keep going and going. And both concepts often work together in a calculus, especially solving complex problem. So for the first one, integration techniques. So as you can see, use substitutions. So it's basically simplified integrals by changing variable. So it's actually just changing the integrals it's just simplified integrals by changing a variable. So we can see the u is equals to x squared plus 1 while the du is equals to 2x. So you basically just change the variable, and after you change it, you will got this and follow to these rules, then you can got the answer here. Okay, so next I'm going to talk about integration by part. So integration by parts is basically used when you have two functions are multiplied. So as you can see, the formula, you got two variables which is u and v. Okay, so example the question, this you can see x and exponential of power x. So let's say let the u equals to x and the v equals to exponential x. Then once I got the value of u and v and the differentiation of u and v here, then we can sub into the formula. So after you got the sum formula, then we can solve the answer. So before I move to the next, let me go with the summary. So use substitutions is basically handle composition like this, which means it's a nested function, while parts is handle products, which means you have two functions. Okay, next, so what is infinite series? So why we need to use? Because when we need to integrate the functions like exponential power x and sine x. So why we need to do it is because this exponential x and sine x, it can be expanded into infinity series, which means the answer can be infinite. So I'm going to talk about Taylor series and Maclaurin series. So basically both are the same, but the only difference are the value of a. Maclaurin series is stated that when the a is equal to 0, while Taylor series is when the a is more than 0, which means it's not going to be 0. So this is the Taylor series, how it looks like. Okay, and the a is basically 0 unless the question is mentioned. So now I'm going to show you when the a is not going to be 0, how the question looks like. So as you can see the question, derive the Taylor series of the following function about 3 up to the first 3 non-zero terms. From here, we know that our a is not going to be 0, but it's going to be 3. So what's the first step? The first step is we need to differentiate the value of fx. So this is the differentiate first time, then this is differentiate for second time, and differentiate for the third time. So once you differentiate it, you got this value, then you need to sub your x equals to 3, because when your a is equals to 3, your x also equals to 3. It's basically the same thing. So when you sub your x equals to 3, then you will got this answer. So once you got this answer, then you can write into Taylor series like this. Okay, next. So I'm going to tell you what to do when the a is equals to 0, which is the Maclaurin series. So from here, as you can see, the step is basically the same. The only difference is when we move it to the right side, our x is equals to 0. That's it. Then here also the same. we got this value, and we write into the Taylor series, and we got this. So and next, I'm going to tell you how to solve it when the equation have sign. So as the question state, the a is equals to 3. So which means my x also equals to 3. So first step, same, I differentiate it. After I differentiate it, then I sub my x value. And after I sub my x value, I write into the Taylor series. So that's the answer. So last, I'm going to talk about practical application. So for this, it's going to tell you about why is it important for engineering. So the Maclaurin is used in calculator and computer. Like giving an example, like when we're calculating the value of sine 0.5, it will be using the Maclaurin's series. So it basically look like this, and so on. So this formula helps to approximate the value accurately, fast and efficiency, and that's why it's so important for engineering. And that's from me. Thank you.